and welcome to Today I Learned Climate, brought to you by the Massachusetts Institute of Technology. I'm Laur Hesse Fisher. Where are you listening to this episode from today? Maybe you're riding the bus on your morning commute, or taking a leisurely stroll through the park. But chances are, if you look around you, you'll see four walls, maybe a door or two, some windows, because you're in a building. We Americans, we spend close to 90% of our time indoors. In the offices, stores, and factories where we work, the gyms and shops and theaters, and the homes where we relax at the end of the day. But how often do we really notice these spaces and how they're built and why they're built that way?
The built environment has been the shelter that humans needed throughout history, whether it was cave-like structures, indigenous buildings that survive until today, creating comfortable spaces that are also shelters from the environment.
That's Tarek Rakha.
I am associate professor at Georgia Tech and director of the High Performance Building Lab and Program at the School of Architecture and the College of Design.
He also got his PhD here at MIT, where he worked in the MIT Sustainable Design Lab. And as Professor Rakha says, the first thing to know about a building is that it's shelter. It shields us from the rain and the wind and the cold, and the way we build has always reflected that.
Climate resiliency has been at the forefront of architectural practices since we have started building as humanity, using the materials from the environment we're in, and then shaping our architecture to be responsive to the environment.
Think, for example, of the adobe houses of desert regions like in the American Southwest. The native Pueblo people built their homes out of the clay in the area, and those clay walls absorbed the hot desert heat, keeping their inhabitants cool during the day and warm at night. And as technology developed, we found that we could do more than just shield ourselves from the weather. We could actually engineer our buildings so that we're perfectly comfortable all throughout the day and all throughout the year.
It is really a beautiful experience. If you get a breeze on a beach, we want to strive for these kind of experiences in our buildings, and therefore we've invented HVAC, so heating, ventilation, and air conditioning.
Look around for me again. Can you see a fan spinning away, or hear a hum of an air conditioner, or a rumble of a furnace? Our modern buildings work very hard to keep our indoor weather precisely the way we want it.
And that is an energy hog. The energy you need to cool and heat a building is significant.
A modern building is far more than just a shelter. It's more complex and it's busier. We can think of these buildings as machines that turn energy into comfort.
So where we're going to get that energy becomes very important. Of course, historically speaking, we've relied on fossil fuels.
That is coal, oil, and gas. Like, does your home have gas heat? If so, your utility is pumping natural gas through pipelines in your neighborhood and into your house. Your furnace burns that gas, creating the heat that keeps you snug on a cold winter night. Unfortunately, like all fossil fuels, it also creates carbon dioxide, part of the ever-thickening blanket of carbon pollution that is heating our planet. Now, think of all of the furnaces in all of the buildings in the entire world, and all of the coal and gas power plants supplying those buildings with electricity.
Buildings account for 40% of carbon emissions globally. The amount of energy that we use to sustain our lives in buildings is substantial.
Which brings us to yet another way to look at modern buildings, as giant pumps for carbon, working overtime in all their many roundabout ways to take fossil carbon out of the ground and pipe it into the air. Buildings contribute more to that carbon blanket around our planet than heavy industry does, more than growing the world's food, more even than cars and trucks and airplanes. So, is it possible to keep using our buildings as the miraculous comfort machines that they are, but to stop using them as carbon pumps. Well, there are buildings around the world that are already leading the way. For example, have you ever seen a plaque on the side of a building that proclaims that it's LEED Gold or LEED Platinum? That's a certification, which the U.S. Green Building Council has been giving to energy-efficient buildings since the 1990s.
LEED started at a time where this kind of benchmarking was not mainstream, and the focus was not on the climate message or the sustainability message. It was all about the money that you will be saving and the prestige of having the Cadillac of buildings.
Yeah, the great news about low-carbon buildings is that owning one can be a big money saver.
One of the biggest misconceptions that people have about sustainable and energy-efficient buildings is that they are very expensive. Buildings that are sustainable are typically much cheaper than regular buildings because, you know what? You are not going to be using energy in HVAC and heating and cooling. If there's anything that you should be knowing about sustainable buildings is that there is an upfront cost that is going to pay for itself over 5 to 10 years.
So how would we create an energy-efficient, money-saving building with the fancy plaque? Well, to answer that question, we have to start before we even dig the foundation. We have to start with the blueprints themselves.
If we're starting to design a new building, we have to get the geometry right first. The relationship to the sun, the prevailing winds, the landscaping, the correct orientation to maximize solar energy and access to light. Then we have to be focusing on passive systems. Passive systems are systems that do not use energy that comes from fuel. So for example, glazing that allows for the sun to warm up the space and the shading system that blocks it in the summer.
Like the ancient Pueblo's adobe structures, our new low-carbon building is laid out to take maximum advantage of nature itself.
If you're in a climate where you really need to heat and retain the heat in, there's no way around building highly insulated buildings. And so the choice of the exterior materials, whether it's going to be brick, concrete, fully glazed facade, etc., really matters, not just for the energy efficiency, but also for how comfortable the environment would be within the interior spaces.
Our choice of materials matters for another reason, too. If you can see a steel beam where you're sitting or a brick wall, if you're in a building with a concrete foundation or aluminum siding, these are energy-hungry materials, and the building industry uses a lot of them. In fact, there are estimates that about 25% of the carbon pollution from buildings comes just from manufacturing and construction. Today, thanks to top-of-the-line buildings like the ones that we're imagining, there is a growing market for cleaner materials, whether that's local earth and stone or engineered wood or ingenious new ways of making low-carbon concrete and steel. We also have excellent tools to deal with the other 75% of our building's carbon.
This is the energy that we use on a day-to-day basis. All of the energy that is used in heating, cooling, lighting, equipment, appliances, etc., all of these use up energy.
Yeah, like remember that gas-burning furnace that we talked about? The same work can be done by an electric heat pump, which is kind of like a reverse air conditioner. They are so much more efficient than furnaces that they typically cut our carbon pollution by more than half, while still keeping our buildings nice and toasty. And if we get that electricity from low-polluting sources, like solar, wind, nuclear, and others, we could heat our building with almost no impact on the climate at all. Our buildings might even make that clean energy themselves, like through rooftop solar panels.
Because if we get it right, we can build buildings that rely on their own energy and don't need anything from the grid. There are such things as zero energy buildings that are so energy efficient that with just solar, you can get the energy to zero.
The highest performing buildings today have designations like LEED Platinum or a living building or passive house, and they are already delivering modern comfort without the pollution. The challenge, of course, is getting every building to that level. and it's a substantial challenge.
If we are to build all of our new construction to exceptional standards, that would have a clear impact. However, more than 50% of the built environment in the United States was built before the year 1980. And therefore, we really have to be considering how to retrofit existing buildings, because the opportunity to build new buildings in urban settings is actually very limited.
Okay, so I live in a home built around 1905. And gradually over the years, my family has worked to make this house operate like the buildings that we've been talking about. And so we followed the textbook of what to do when retrofitting an old building. So we added insulation to the outside walls and flooring and replaced some leaky windows. We also did some pretty cheap but effective fixes called weatherization.
Weatherization, in the context of limited resources, become really impactful. So weatherization would be, for example, using weather stripping around the window frame. This is important because you're no longer losing energy to the environment.
And with that all done, an old building like ours can be ready for the newest, most energy-efficient electrical appliances, like heat pumps and electric water heaters, which is what we have. And over time, we have found that our energy bills are much lower, and our house is much more comfortable. Like, I don't wake up on winter mornings clinging to my blankets anymore. And yes, because we are nerds and we track this kind of stuff, we've also calculated that our home emits much less pollution than it did before. Now, I want to be clear, this took us a few years and we invested money into it and we were motivated. But how do you motivate the owners of the millions upon millions of buildings that exist out there today or that are about to be built? Because even though high-performing buildings are possible and cost-effective and are being built today, most buildings are not being built to that standard.
It has become more mainstream, yes, but unfortunately, mainly for those who are building in an urban environment as well as larger scale buildings. Those who are building, for example, single family homes in rural settings or suburban settings, it's not there yet, even though it constitutes a significant portion of the built environment.
Yeah, most buildings are built to code, meaning that they meet the minimum energy standards that the local law requires. They're not aiming to be high-performing buildings. And it's worth asking, how can more buildings be built better? The most climate-smart buildings are also the most comfortable and the cheapest to heat and cool in the long run. The materials and the know-how exist. And with each new developer who makes the choice to build a high-performing building, the markets shift a little, opening up the labor and the materials and the knowledge and the expectations that buildings are built this way.
We know now about the built environment more than we've ever known in any point of history. We have these sensors that are allowing us to measure at the circuit level of a refrigerator at the time span of a second to allow us to make real-time decisions for energy efficiency. All we need to do is activate it, like tap into it, have it as a mindset. And that is basically my advice. If there's going to be decisions on building new or upgrading buildings, we can't really build the same way we've built 20 years ago. We have to be thinking about building more sustainably and keeping carbon emissions as low as possible.
That's our episode for today, but there is plenty more TIL Climate at tilclimate.mit.edu. And as always, we'd love to hear who you are and why you listen to the show and what questions you have about climate change and climate solutions. Please email us at tilclimate@mit.edu or leave us a voicemail at 617-253-3566. TIL Climate is a climate change podcast of the Massachusetts Institute of Technology. Aaron Krol is our writer and executive producer. David Lishansky is our audio producer. Michelle Harris is our fact checker. Grace Sawin is our student production assistant. The music is by Blue Dot Sessions, and I'm your host and senior editor, Laur Hesse Fisher. A big thanks to Professor Tarek Rakha for speaking with us, and to you, our listeners. keep up the climate curiosity.